Hello there, this is exercise 4D for decision maths. We're going to have a look at what was formerly called the Chinese Postman algorithm, hence the picture of Postman Pat there, and more recently route inspection problem. But quite often on the exams now it just says find the least rate cycle using every arc. So let's have a go at this and you'll see what I mean by it. So first of all, the key here is to realize that we're trying to find a route which goes down every arc and gets back to where we started. And that's the idea of the postman scenario. Incidentally, it's called the Chinese postman algorithm formerly because it was a Chinese guy who invented it. And the postman part of it, as I say, is the idea that if you was delivering letters down a series of streets, and I'm making up a route here, aren't I? Some kind of network which has got a load of streets, and the postman would have to walk down all the streets because someone on that road would have a letter. You'd have to walk down and deliver that person the letter. Even if it was just one, you'd have to walk down it. And so I'm just making up some kind of, I don't know if it's a good one or not, but and the key here is what we've got to do, as it says here, is identify odd vertices, and by that you count how many arcs come out of it. That one's got 3, so that one's odd. So I'm going to put a circle around that. 1, 2, 3. That one's odd. And we've seen this idea before that odd vertices matter. That's got 2 arcs. That's no good. 1, 2, 3. That's 3. That's interesting again. What's this? This is also 3. So I didn't intend to do that. Sometimes you get, I don't know, 1s or 5s, I suppose, and so on. But here I've got 4 odds. And it's quite typical, actually, on a Chinese postman problem, this idea of route inspection, to get 4 odds. It comes up loads. You get very often you get 4 odds. And that's because 2 odds is too easy. And as we'll see later, 6 odds, 8 odds, 10 odds is really, really hard. Remember, please, that odd vertices always come in pairs. And so when we identify our odd vertices, in this case these 4, you kind of pair them up, trying to find the shortest way of pairing them up. Because one thing you've got to do is effectively go down those roads twice in order to get back to where you started off. Now remember, if you had no odds, if you have, I missed out the O, if you have no odds, this is called Eulerian. And then on an Eulerian graph, you can just draw straight round. If you have 2 odds, it's called a semi-Eulerian. And you can still draw all the way around, but you end up in a different place. So you'd have to kind of get back to where you started. And it's that getting back to where you started bit which causes the additional routes to be required. And for 4 odds, it's neither of them. So it's not Eulerian, it's not semi-Eulerian. And you're going to have a proper route all the way around that you're going to have to find. It's not so obvious. That's why they tend to do it. So let's have a go at this. We're going to have a look at a question. Example 1 then. So this says we've got postman must deliver letters, as is the Chinese postman algorithm typically is. And considering this as a route inspection problem, identify his optimal route. Now, okay, look, so my very first job is identify 1, 2, 3, 4, 5. Identify odds, and I think that's an odd. It's 5. 1, 2, 3, 4, 5 coming out of there. 1, 2, 3, that's an odd. 1, 2, 3, that's not. 1, 2, 3, 4, 5, that is an odd. 1, 2, 3, that one's an odd. So we got 4 odds. I did say we very often get 4 odds, and sure enough, this one you do. So what have we got? Now, we then pair them up. I'm going to say M and N together. So you can see M and N can go together. And if they go together, the R and the P go together. And if I just quickly work out the shortest way, for M to N is obviously 4. We're looking for the shortest route between these 2 pairs, R and P. Now, it's tempting to think, is that actually, I think it's the 3 and the 2 makes 5. Yeah, I'm happy with that. That gives me a total there of 9. Okay, so far so good. Now what we've got, now M doesn't have to go with N, which I did there. It could go with the R. That's the most obvious next one. What does MR do? Now MR is 6. Okay, I like that. And if I do M to R, I've got to do N to P. N to P. Now N to P, again, tempting to go over there. Actually, I think 5 and 2 make 7. But either way, you still get 13, and 13 is higher than 9. So first pair seems to be my best one. Let's see my final one. Well, this just looks miles apart. M to P is my final option. And if I pair that M to that P, I've got to pair the N to that R. So shortest routes for those two. What's M to P? 4, 9, 11. I don't. Oh, I could go that way. It's still 11. 11's my best, and that's M to P, and N to R. Oh, I was going to say 11, then I was going to say 10, but actually 5 and 3 makes 8. Either way, it doesn't matter because that makes a total of 19. Now, I suppose I've got to add up all the numbers for all the arcs. And this sometimes is given to you in the question. I just paused because I was looking up there, but no, they're not. So 15, 19, 30, 40, 55, 60, 70, like adds up to 72. Now here's the rule that you must do. Having found my best pairing of M to N, which way was M to N? Basically it was this route here, wasn't it? I'm just going to do that in dotted line so you can see it. That's that route. And then we did R to P, which I said was 5. Now, interestingly, it's this way round here. And then we had up to here for the extra 2. Now these dotted paths we've got to do twice. So I've already counted them once when I added up all these numbers, but I know I'm going to have to do them twice. So that 9 I got from that, I'm going to add on, and that basically tells me my optimal distance will be 81. Now, if I try to find a route for this, I suppose that we can start off somewhere. I'm going to start off down here, R. Why not? So if I go to R, I want to go to M, I suppose. In fact, I'm going to pick a different pen so you can see the route I'm choosing. And I'm going to pick R, let's write over that again, to M. So that has gone all the way around to there. And I'm going to come back again. There we go, back to R. Now I suppose having done that, I can go up to N. And sometimes when you notice this goes to a bit of a dead end, so I'm going to go straight over there and straight back in. That's the road I've got to do twice, or one of them once anyway. So that went to M and back to N. Now I want to really go over to here to P, and again I'm tempted to go straight back again. So that's P back to N. Now I'm here. Oh, I'm going to go down to Q, up to P, and again there's another dotty one where I can do it twice. I have to do it twice. So what's that then? I went to Q, I went back to P, and I went down to Q. Now again, notice I can go down to R that way. Could go either way really, but notice this is the dotty one, so I can go back up to here and back here again. So I will get back, and that's the critical thing there. I got back again. So I went to Q and I went to R, and that's my optimal route. And I've got a couple more examples for you. Example 2, it looks exactly the same. Does it say route inspection? No, but it kind of gives us, it find the best route. Look at odd pairs, it's route inspection problem. So the same trick I'm going to do is basically to, first of all, find my pen. Where's my pen gone? There it is. Odd vertices, 1, 2, 3, that's an odd. 1, 2, 3, that's an odd. 1, 2, 3, 4, 5, that's an odd. That's a 2, that's not odd. 1, 2, 3, that's odd. 1, 2, 3, 4, that's not. Okay, so I've got my odds. So I'm going to put A and F first of all, and I'm going to go C to E. So they are my odd pairings. A to F looks obviously 13, doesn't seem to be an obvious alternative. And E to C, C to E, I can't beat 14, the obvious route, so that makes 27. So A to C, I suppose, next, and E to F for the other pairing. A to C looks like just straight down, 10. And I don't think I can beat 10. That looks like the best. And then E to F is obviously 5, isn't it? can't beat that. So that gives me a total of 15. Can't see any smaller ways of doing those. Sometimes they're in obscure places, these routes, and kind of they've been deliberately done to make you miss them. So A to E is my last one, C to F. A to E, I'd be 14 round the corner there. That's the best I can do on that one. And what's the other? C to F. C to F, well, 14, 19, 13. I've got a 13 there, which makes 27 again, which means this is my best one again. It's my second one again. So what's my optimal distance? Well, I've got to add these together. I'll probably do the same as last time. I'll pause it and get a total. Well, I make that 98. So I'm going to write 98. And of course, that's not my best number here. Well, it's my best number, but then I have to do something to it. I have to add on my smallest one, which is 15, which gives me a total of 113. That's my shortest route distance. Now, what route should we suggest? Well, let's again pick an odd vertex to start with. I'm going to pick E, and that means I've got to get back to E. And if I do this again, I'm going to go round. I'm going to go round there first of all. Just get that out of the way. And I'm going to go down to B afterwards. So I'm going to go E to A to B. Now already I've just spotted a slight problem now. You see, if I do what I've just done, and I've got to get back to E, of course, how am I going to get out of there again? So this is something that does happen. I'm going to go round here. Or I suppose I've still got to identify which ones am I going to use twice. This might save me. A to C. A to C. That one I've got to use twice. All right, then. I'll put a double notch on the ones I'm going to use twice. That was the 10. E to R. Now I think I'm a bit happier. I can get back to A. All right, then. E to A to B. Now I've got to use that twice. I'm going to go back there straight away. I'm going to go back to A because that was my problem one. I don't want to do that. So I've gone there and back again straight away. So I shall get there. There you go. And I shall now go down to F. Now I can use this twice, so I might as well just do it straight away. There we go. So I'm gone to E and I've gone back to F. I'm going to go across to B. Okay, well, I'm tempted to go down to C. Yeah, this will work. This will work in my head. I reckon I can go down to C and back up to B. I can go all the way to E. That's fine. And then I go around that little triangle. 14, C, D, E. That's a bit of a mess, but I think that works. And again, it's not the only route. You may have a better route. Well, not a better route, an alternative route. Let's do a third example of this. So the same thing, at least this time they've added them up for me. It says they add up to 213. But we're going to do the root of spectrum problem. That's an odd. 1, 2, 3, that's an odd. 1, 2, 3, 4, 5, 6, no. 1, 2, 3, that's an odd. 2, 2, that's a 3 there. So again, notice it's very, very common to get 4 odds, and each of the examples we've looked at so far have got 4 odds. So I'm going to go P to Q is my first one, and therefore U to T is my second one. Don't know what they are. P to Q. Can I beat the obvious 23? No, I can't. So that's 23. Now U to T, I can see a 22 there, not so obvious, but 22 looks best, which makes a total of 45. Be surprised if I can beat that. Okay, on that basis, now I've got P to U maybe, and if I do that, it's Q to T. Sometimes these, Q to T looks miles, but you don't know, do you, until you see the numbers. P to U, I think I should put a little dotted line to separate these. P to U, I think it's 25. 12 plus 13. So I'm going to go with that, 25. Of course, there's a big chance you're going to get one of these wrong in the exam. So it's worth, when you're doing this properly, just checking. Q to T, Now I reckon that 29 looks right. 729. It's a big old number, but you will be judged, I think, and expected to get these numbers right, these totals right. I reckon that's 54. Now, if P to T, it looks a long way away again, and U to Q looks a long way away again. But you don't know, do you? P to T, I reckon it's 21, the 12 plus the 9. And the UQ, just looking at that, from U to Q, well, what have I got? Oh, it's got pens just one with. That looks like that's 20, and I think that's 33. Now, again, it's one of those where it doesn't really matter. 54 again, so that's beaten once again by that 45. So it tells me the total is 213. 213 plus my 45. What's that? 258. So my best distance, on my third example here, is 258. If I can add. Now, what is my best route then? So which ones am I doing twice? PQ is 23. Oh, that's straight across there. That's an easy one. So I'm going to do that twice. And my UT, what was that? That UT is 22. So from UT, so that's the 13 plus the 9. So I've got to do that twice. So again, let's change my pen. It changed to blue to red, and I might go back to blue. Suggested route. So let's start. Let's start at. I'm going to start at P. Why not? So if I go to P, I'm going to go P down to Q down to R. So I've got to there, and I want to go across to V. So I'm going to go there to there, back to V, up to Q, and since I'm allowed to do this twice, I'm going to do it straight away there, across to P. What am I going to do now? Well, I want to go down to U. I'm going to suggest I'm going to go T to S, up to V. Now I've got to do those two red ones twice, so I'm going to do them straight away. To T to V. I shall go across to U and back to V. And then I think I'm done. I might be getting better at this. Then I get to P. And that's my, well, an optimal route, not necessarily the only one. I keep on saying this. Okay, so what have I got now? I've got, look, I've said up to now that this usually happens with 4 odd vertices, and I think I've only ever seen this like as an apart question. I tended to make my class do this, so I might do this now just so you see this. It could come up with 6 odd vertices, or 8 odd vertices, or 28 odd vertices. If you get silly numbers of these, then you're in trouble. But 6 odd vertices, I think, is just about the maximum that you could be expected to do. I've started it for you, so I've identified then that A, B, apparently A and B are odds. I know this from over here. D and E apparently are odds, because I've already identified the pairs F and G are odds. And in fact, only C isn't an odd. So I've paired them up. A to B is 11, can't beat 11. D to E looks like 15 is the best. And F to G, where's F to G? F to G, what's that? 28 I can do. I'm not going to beat 28. So there's my initial pairing. Pairings, notice there's 3 pairs in each pairing, set of pairings now. 20, I reckon that's 54. And what you're meant to do then is you go, well, I could get A to B, yes, but then the other 2 get switched. So that's still 11, and that will be 11. D to F is 15. I'm not going to beat 15. E to G, where's E to G? Well, that's straight across there. I'm not going to beat that. That looks quite low, actually. That's 30, 42, I think. So already I've got a better pairing. And my A to B is D, G. So I've got these letters. I've got, so that presumably is F, E is the last one, or E, F. However I choose to write it. Now D to G, is all the way down to there. I definitely get a 30. I'm not going to beat 30. And E to F, well, they definitely is 12. But either way, I'm not going to beat 42. That's 53. So far, this is my best one. A to D, B to E. What are my A to D, B to E, and F and G, I think, is my last one. I think that's right. Effectively, I've just swapped those round. So A to D is obviously 22. B to E, now that's up here, all the way down here now, 15, 31, 31, 31 seems to be the best. And F to G, I've already done F to G. Now, after a while, you start realizing some of these are repeating. So F to G was 28. I've either got it wrong there, and now I've got it wrong again, or that's as good as it gets. 81 is the total. Now I've got A to D once. I can kind of go A to D again. I'm going to do it 3 times. And I had B, E, F, G, so why not I have B, F, E, G, and B, done E, B, G, E, F. Now E, F I've already done is 12. And the others I've already done. A, D I know is 22. So you can speed this up a bit. You can see why I'm saying this is at the kind of limit of what you could be expected to do in an exam. Now B to F I don't think I've done yet. B to F, where's F? Well, that's just 19, presumably. Don't think I've done that yet. So there's 19. B to G, I think I must have done that by now, surely. No, I don't think I have. B to G. That looks like a 13. That gives me a total of 34, 37, 47. 20, 30, 40. And E to G is again not the best, but E to G is straight across there is 16. Gives me 41, 57. And now you can see I've done AB. I've done AD. I haven't done AC, so why didn't I do that? Oh, AC isn't one of them there. I don't want to do that. AB, AD, AE next. So I'm going to do that, end up doing that 3 times. And with the letters left over, I just kind of mix those ones up. So AE is now what I'm doing. I've got BD and EG. And I've got BE. Yeah, no, I've already got it. So that's FG. BF and DG and B to G and D. What I'm going to do, actually, I'm going to pause my video and just whack them all out because I think this is taking a bit long. So I've just gone through all of those, and typically I've left one to do, but typically the one that I said at the beginning looks very low, was the lowest. And I suppose this highlights, will this come up as a part question? Possibly. But I just wanted to show you this so that you know that this is where it, a full question would be. And I've gone through every pair. Anyway, which ones have I got left? I've got AG on this one still to go. I've got B to D still to go. And that leaves E to F. So if I just work out these 3, then I'll know for sure that whether or not 42 is my best one. Anyway, what is it? It's A to G, I know is 24 because I've just worked those out. B to D, I've probably got somewhere up here. B to D, have I got it here somewhere? B to D is 33, assuming it was right last time. And E to F apparently is 12. Oh, so have I got that right? B to D. Let's just have a look at B to D because I'm not convinced of the right. 33 looks the best. Oh, 33 is right. And then E to F looks like 12. The only thing I don't like about that is that it implies this one up here is wrong. A to D is 22. And B to, all right, A to G and B. So they're just different but the same. looks like it. I'm not even that fussed as to exactly how accurate it is. Perhaps one of you will pass a comment to me in the comment section on YouTube, because 57, 69, if I have made a mistake, you can let me know. So look, the lowest one is 42. Apparently they all add up to 152. So the optimal distance now again is 152, assuming I've done that bit right, and it would be easy to have gone wrong, is 194. Do I think you're going to get asked to do all of that? No. The questions I've seen kind of give you part of that question. So it's worth looking out for something like that, where they say to you, what happens if you get 6 odd nodes or something like this? A route, well, presumably this is the same thing. I just need to work out which ones I'm going to do again. A to B is 11. I've got to do that one again. D to F is 15. I've got to do that one. Yeah, it's just the obvious ones here, isn't it? So those 3 I've got to do again. So let's start somewhere. We're going to start at A to B and back again. A to B. In fact, I need to get back to A, don't I? So let's not do it straight away. I'm going to save that till later. Let's not cut my options off if I've just got to go home. So I'm going to go C. I'm going to go down to G. And I want to go up there, you know. I want to go back to B. I'm going to go then. Let's do that. I'm going to go to A. I've said I'm not going to, and then I've done it. I might regret that, but I shall do that A. I shall come down to 22 for the, that's a D. I'm going to go across to E. Now I think I better do this straight away. I'm going to go to G and back to E. I'm going to go up to F. But then again, I've got to do this twice. So I'm going to go to D and then back to F. I'm going to go up to B. And I'm allowed to do this one twice. So I shall go back over to A. So there again is a possible route. I hope me showing you those slowly has made you think it's not that hard. You just got to take your time. So there's a couple of special cases I want to show you as well. So here I've got what difference does it make if I start and end at different points? Well, basically, what looks like an odd isn't really an odd necessarily. So by that I mean, I and this question have got 4 odds. It's A, definitely an odd. C, yes, definitely an odd. E, yes, it's got 3. And H has got another 3. But look, I want to start at E and end at H. So the fact that it's an odd, this is basically what's going on. The fact that it's an odd doesn't really matter. So I'm going to discount that one. And I'm going to discount that one. I'm going to just have odds, which are my other 2, A and C. And the fact that they were odds don't count, because that one of them was a starting point, one was an end point. It doesn't matter that it was an odd. So I've only really got A to C. What's the shortest way between A and C? That's 240, that's 350. I think 350 is the shortest way. And so now all I would have to do is add them up. I'm going to add them up now. Well, I've just grabbed my phone to add those up, because I didn't have a calculator to hand. But I get the total to be 2,410. Again, pop a note in the comments if you think I've added those up wrong. And it only wants the length, so I can just add those together. It's 2760. Doesn't say what the units are. And I've got a similar type here, where I mean, this post lady is going to deliver letters down these roads. I've got some units for once, and most of my questions haven't had units. But basically, a 12 means 1200 then. She can be dropped off at any of the vertices and picked up from any other vertex. Find the length of her shortest route. Now, again, my idea here is I can go from any to anywhere else. So it would seem that I'm just going to see. So that's an odd. It says D is also an odd on my list there. It says E is an odd. Is that right? Yeah, obviously it's on its own. G is an odd. And I'm assuming they're the only one. 1, 2, 3, 4, 1, 2, 1, 2, 1, 2, 3, 4. So they're my odds. Now I can go from anyone. So let's find these roots that we've got. So B to D is 14, 13. I think I get the shortest. B to E, that's a long old way, isn't it? 16, 22. Can I beat 16, 22? No, I don't think I can. No, that looks like the shortest. B to G is 21 or 19. I'll take the 19. Now, with these, I've called them linked pairs. I'm not sure if that's the best description, but BD then is 13, and with it goes EG. So BD I've used, EG is 14. Now, what I'm looking for is the shortest one, because I can start and end in different places. You see, what that basically means is, although all these four are odd vertices, I don't necessarily have to treat them like odd vertices. Hence the idea of this real odd vertices comment I've made. Anyway, let's carry on this table. BE, if I use BE, that means I've got DG to use. DG looks like across the bottom 20. And if I use B to G, oh, that's D to E is left over. And D to E looks like 18. Now, which is my lowest number? My lowest number is 13, the very first one I did. Now, 13 is the lowest number. And by the way, I've added up these numbers. They add up to 97. Or 9700, I suppose, they're in 100 meters, but I'll write 97 for now. Now, I think that means I can do it with an extra 13, which is 110. The total weight from this task is that many meters. If I put the extra noughts on. Now, just to prove this, I think I could probably, so I'm saying this B, please, I did switch pen now, it just switched on me, and the D I'm going to think of as being odds, and these are not real odds, even though they are odds, obviously. So that means that's 13. That came about from the 6 and the 7 there. And that means I should be able to draw around this just using those two arcs again. So let's start at E, because that looks like a tricky one to get back to otherwise. So I'm going to start there. I'm going to go E. I'm going to go up to D. Oh, pen stopped working. There, it's started again. And then I'm going to go up to the C, across the top, down there. Now, this is where I can double up there and back again. I suppose straight away I'm going to do there and back again. And this is where the bit that perhaps it's not obvious. You'll notice I used the B to D. Where I started was an E. I ended up at my other odd, my EG. I didn't need to double those up. And so whatever that root was, didn't ask me for a root, but I could clearly find it. So that's a weird one. There's where it wasn't the case that all four odds were treated as odds. Two of them were, so these were odds. But the EG effectively became evens, and I started at one of them and I ended up at the other one. So just be aware of that. You can get these slightly weirder questions, which expect you to do a little bit more. And this then is the root inspection method. So exercise 4D was from the textbook that I used to use. That's why this is called exercise 4D. But whatever book you're using to practice this, best of luck. And I hope it goes well for you in your exams. All the best.